Okay, picking back up with number 18, I believe. Um, a line passes through a point -2, -3, and has a slope of -4. Okay, so again, when we write equations of a line, it says write the equation in slope-intercept form for this line. Now you can do it like we did in class the first way, where you use slope-intercept form, and those of you that know that continue to do it. I'm going to use point slope form. So the first thing you have to know, there's 3 steps. The first thing is the slope. They give us the slope so we can go straight to point slope. Now point slope is y minus y1 equals m times x minus x1. Where x1 and y1 are the point that they give us, m obviously is our slope. So here's our point. This is my x1, y1. Okay, so I'm going to just plug in what I know. Y minus a -3 equals our slope, which is -4, and x minus our x1, which is -2. Double negatives, the only time I ever change my signs. Now, step 3, get y by itself. So I'm going to have y plus 3 on the left side. I'm going to distribute this -4. So I get -4x plus, nope, minus 8. Let me erase that a little bit better. Minus 8. Now I'm going to subtract 3 from both sides. Y equals -4x minus 11. Now you can actually check this answer. Okay, the first thing is, did we write an equation of a line that has a, well, first of all, it's in slope-intercept form. This would be point slope form right here. I'll always ask for this. Does it have a slope of -4? Yes. Is -2, -3 on this line? Well, you can do this by hand by just plugging in -2 in for your x, and we hope that plug in -3 for our y. Well, this gives me 8 minus 11 gives us -3. Or you can even check it on your calculator. Go to y equals, plug in -4x minus 11, go to your table, second table, and look for -2, -3, and it is right there. So I know that equation of a line is correct. Number 19, write an equation of a line that passes through these 2 points. Okay, well, when, I'm going to erase this part, the checking part, so that I can do this problem. Step 1, got to know the slope. Well, they give us 2 points. We have to find the slope. So connect the first ones, connect the second ones. I'm going to say 1 minus its partner of -5. -5 minus its partner of -1. So double negatives. Here I have 6. On the bottom I have -4. That is going to reduce to -3/2. Okay. Step 2, plug it into point slope. Now I'm not going to write this anymore. If you do not know that formula, I would write it every single time until I have it down. Not just sometimes. Always write it until you learn it. Y minus. Now you can pick either of these points. I think on my paper I picked this point on my answers. Let me just double check. Yes, I did. So I'm going to use this point just to prove that it'll work. Because again, both of these points are on the same line, so they need to both work. So y minus one of the y values. I'm just going to use this point here. So it's going to be y minus 1 equals my slope, which is -3/2, times x minus the x1, which is the first of 1 point. Okay, this gives us a double negative. So it becomes a positive. Now step 3, solve for y. Y minus 1, I'm going to distribute the -3/2. I get -3/2 x minus 15/2. Okay, now I'm going to add 1 to both sides, and I get y equals -3/2 x. This is going to be 2/2, so it's -13/2. Okay, so here's what I have to do. So I've got to find whether or not my 2 points are on this line. So -3 divided by 2x, I know I didn't clear it out, but that's fine. 13 divided by 2, as long as it looks like this. Yes. Okay, now I'm going to go second table. I'm going to go to -1, -5, there's that point, and the other one is -5, 1, and there it is. So I know my answer is correct. Okay, now in 20, we've got to write 2 equations of lines. One that's perpendicular to this line and one that's parallel to this line. Okay, well, perpendicular have opposite reciprocal slopes. Really, it's called negative reciprocal slopes, but I don't like the word negative because some of my students might think it's just always negative. Parallel lines have the same slope. Okay, so what we got to do is look at this line, get it in slope-intercept form. It is, even though these are mixed up, this and this is the exact same thing. It doesn't matter to me if you have it as -1/5 x minus 2/5, because the way I teach it is your slope is always in front of your x. So here it'd be -1/5. So this line here has a slope of -1/5. If you look at it here, -1/5 is in front of your x. That is your slope. Okay, so yes, technically this is slope-intercept form. So if I'm going to use the same slope to write the equation of a line right here for parallel, on this one, for step 1, I am going to use that m equals -1/5. Up here, I am going to flip it and change the sign. So it's going to be a +5/1, which is just 5. Because it's opposite, meaning opposite sign, or negative reciprocals. Negative, negative gives you a positive, so that's why I put opposite. Reciprocal means you flip it. Okay, so now you have the slope. Oh, that's all we had to do. I was thinking we were going to have to write equations, so we didn't need step 1. We found them. Okay. Now be careful. Well, like in this one. Okay, that's what I was getting ready to say. But okay, consider this line. Find the equation of a line that's parallel. That means it's going to have the same slope as this line. And then we're going to write an equation that's perpendicular to that line. Well, what we have to do is we've got to find the slope of this line before we can write a parallel or perpendicular, because remember, we need same slope here. So when we write the equation of a line, the first step is know your slope. Okay? And I guess I'll do the first one, then I'll come back and do the second one. Okay, so let's find the slope here. So what we got to do is get it in slope-intercept form. Take that 8x to the other side by subtracting it. We are going to have 3y equals -8x minus 7. Divide everything you see by 3. Y equals -8/3 x minus 7/3. Okay, so the slope of this line, we just did all that work just to find the slope, which is -8/3. Okay, so now we can write a parallel line, because that means we're going to use the same slope. Which means -8/3. Okay, so let's do that one first. we are going to first find the slope. Let's do A right here. I don't know where B will go yet. Step 2, point slope. It's going to pass through 8, 6. So it's y minus 6 equals negative 8 thirds x minus 8. Y minus 6 equals negative 8 thirds x. We're going to distribute that. Plus 64 thirds. Now we've got to add 6 to both sides, and because this is step 3, so we get y equals negative, let's try negative 8 thirds x plus 18. I think it's going to be 82 thirds. I don't have you guys here to correct me, so I better check. 64 plus the 18 gives us 82. Okay, I just know this is 18 thirds, but you have fractions. Okay, you can use your fraction key. Well, let's try. I thought I was hitting it. Alpha. Well, I thought that's how you did the fractions. Maybe this one doesn't do it. Let's do it this way then. It doesn't really matter. Negative 8. Oops, no. Let's do 64 thirds. I can't even use a calculator, but oh well. 64 thirds plus 6, and we get 82 thirds. Okay, so is this parallel to this line? Yes, they have the same slope. Is this point 8, 6 on this line? Well, you go to y equals, clear it out, negative 8 thirds x plus 82 thirds. Go to your table, and we're going to look for 8, 6. That means I got to go way down here. And there it is. Okay, so that one's right. Now, for the B part, this one right here, we know we are going to have opposite reciprocals or negative reciprocal slope. So that means my slope is going to, let's do step 1, m equals, opposite means if this is negative, our slope is going to be positive. Reciprocal, we're going to flip it and get 3/8. Step 2, we do point slope form. Y minus 6, using that point right there, equals 3/8 x minus 8. Okay, so we're going to have step 3, solve for y. Y minus 6 equals 3/8 x minus 24, oops, let's try minus 3. I was going to say 24/8. That gives us 3. Now we're going to add 6 to both sides, and we get y equals 3/8 x plus 3. Okay, now, first thing, does it go through this point? All right, well, let's 3/8, right? Yeah, it's just faster. Let's do it all over again. 3/8 x plus 3, second table. And there's my point right here, 8, 6. So it goes through the point. Now, you could look at the graph to find out if it's perpendicular to this line, but you have to put your calculator in another zoom, and you'd have to know how to do that, which I'll show you in just a second, okay? But when you have, if you know negative reciprocals, when you multiply them, they should give you -1. So if I take my original slope of -8 thirds and multiply it by 3/8, that does give me -1, so that tells me that those two lines are perpendicular. It always multiplies to give you -1, their slopes, okay? The other way you can do it for visual effects, okay, this one is the one that we just did. Our original line was negative 8/3 x minus 7/3. Okay. If I graph these, I think okay, in order for the perpendiculars, we're going to go zoom 6, let it graph. Then we're going to go zoom 8, enter. That's going to put us in a different zoom, okay? Zoom 6, let it graph, because if you start hitting zoom again, it doesn't really work. See, this one doesn't. This corner doesn't quite fit in there. And that's just because of the way that the graph looks. Zoom 8, enter. Now these are the perpendicular ones. Okay, now you can take the corner of your piece of paper and put it in any corner and it forms a right angle. Okay, so that tells you that they're perpendicular. They fit perfectly. Okay, right in there. Okay, now is this one parallel to our original one? Okay, well, go back to your y equals. This was your original one. This was our perpendicular one. So I'm going to clear that first one out. That was this one. I'm going to plug in this one. Negative 8/3 x, which you already know they are because they have the same slope. Okay, but just for visual purposes, no, I think we're in zoom 8. We are still, but yep, there it goes. Okay, so it works also, but I'm going to put it back in zoom 6 because that's what most of the time we're going to be in. Okay. Alrighty. Yeah, see, it doesn't actually zoom 8 looked nicer, but it's okay. You need to know what these different zooms look like anyway. Most of the time, if you're going to use zooming in and out, when you hit 2, you have to hit enter. When you hit 3, you have to hit enter for it to take it, and same thing with 8. So, but most of the time, we're just going to be in zoom 6. Okay. Now, this one right here is one that people miss on the test. Okay. It says find the average rate of change. Well, remember, average rate of change is just slope. So I'm going to do this work down here. Well, you know how to find the slope. It's the difference in your y's over the difference in your x's. Now this is how it's going to be written. Well, remember, this here stands for y. That's all. So when x is 3, I want to know what y is, and that'll give me a point. So I'm going to find f of 3. That tells you that my x is 3. So wherever I see an x, I'm going to put a 3. So it's 2 times 3 squared minus 5 times 3. 9, 18 minus 15. So I get 3. Okay? If you don't trust yourself, you are going to do, oops, I don't know why I'm doing it like this. I'm typing it in just like it says. I didn't really have to. Minus 5 times 3. And that's it, right? And then you get 3. Okay? So this here is the point. Let me erase this. So we have one point that is 3. When we plugged in 3, it kicked out 3. Then we're going to find our y value when our x is 8. So oh, you know what? Just caught this. This is a negative 2. So that is going to change this. Glad I caught that now. 9, this gives us negative 18 minus 15. That's going to give us negative 33. Not 3. Kind of a big mistake there. So just double check your arithmetic. Good thing I caught it, because you aren't here to tell me I made that mistake, even though I'm sure some of you are at home going, wait a minute, that's not right. Okay, so we're now going to do negative 2 times 8 squared minus 5 times 8. And again, you do not have to do this in your head. You can plug this in wherever. Now you can store it. I didn't do it this time. I don't really know why. But you can store 8 under X and then just plug it in like that. And you're going to get 168. Okay, so this one here is the point 8, negative 168. I did not do anything difficult. You probably have already done this already in this review because I can't remember now. If not, we'll be doing more. So that's how you find your y. Okay, this is your input. You need your output. This is your input. That's your output. Okay, so that is, now we have, just find the slope. Connect your first ones, connect your second ones. Start with that. So instead of calling it slope, we're going to call it an average rate of change. But you're going to do the exact same thing. Negative 168 minus its partner of negative 33. Then you're going to go 8 minus 3. On the top, we got a double negative. It goes to a positive. When I say negative 168 plus 33, that's going to give me a negative 135 over 5. Then when you divide that out, you get negative 27. And there's your average rate of change. Okay. Next page. Okay, now number 23, it's not labeled 23 because it's on the page before that, but 23 is right here. Same exact thing as we just finished doing. I've got paper, my pens are all over the place here. Okay, so let's see if we can clear that up a little bit now that I'm already 20 minutes in, but sorry. Okay, so we are going to first do the exact same thing. We're going to find f of 2, and then we're going to find f of 6. That's going to give me 2 points. I'm going to say negative 2 times 2, which gives me negative 4, plus 9 gives me 5. So this is the point 2, 5. Right here, negative 2 times 6 gives me negative 12, plus 9 gives me negative 3. So that is the point 6, negative 3. Now all you're going to do is find the slope. And again, I write them side by side just so I can do this. Because when I work them up and down, I just have a tendency to make mistakes. But you do you. Average rate of change. I'm going to say negative 3 minus its partner of 5. Then I'm going to say 6 minus 2. I get negative 8 on the top. I get 4 on the bottom. So my average rate of change is negative 2. Okay. The number of bacteria in a culture increases rapidly. Okay, so it's increasing. That means our slope's going to be positive. The table below gives the number N of T of bacteria at a few times. So T is in hours after the moment when N equals 1,000. Okay, so once it reaches 1,000, then all the hours after that they started counting. Okay, so find the average rate of change. Now here you can pick any 2 points. Any 2 points. Oh wait, no you can't. Sorry. It says from, I wasn't reading that. I just read the first. Don't do like me and skim the problem. From 0 hours to 8.5 hours. Okay, so we've got this here to this here. Because if you use 2 other points, it's going to change. All right. Unless it's a linear problem, maybe. Okay, so we've got 2 points. We've got 0, 1,000. Well, here, let's just do it right here. 0, 1,000. And 8.5, 2,105. Time is always, you'll notice that time is always our x. Okay, average rate of change. connect the first ones, connect the second ones, okay? So we are going to do 2,105 minus 1,000, and then you're going to do 8.5 minus 0. So up here we're going to get 1,105. Down below we have 8.5. When you do that, I gotta be careful not this cord for some reason might knock my the audio out. Okay, so 1105 divided by 8.5, and we get 130. Okay, notice that's 130 bacteria per hour. It's very easy to see. The top numbers were bacteria, the bottom numbers were time. So your X is your time, your bacteria is your Y's. So this would be 130 over 1, but we don't write the 1. Find the average rate of change for the number of bacteria from 11.9 to 13.6. So we're going to do these two. Okay, so one of the points, I guess I'll just do it here, 11.9 comma 3380. The other point is 13.6, 3992. So we're going to connect the first ones, connect the second ones. Start there. We have 3,992 minus 3,380 over, if we start here, we got to start here, 13.6 minus 11.9. Okay, so when you subtract the top, oops, this should be a 2. Glad I fixed that before I did it wrong. Okay, that gives us 612. 13.6 minus 11, that's going to give us 1.7, but I better double check. Yeah, 1.7. Now we're going to do 612 divided by 1.7, and we get 360. Again, this is bacteria over time. So we'd have 360 over 1 when we divided, but we don't need the 1, so it's 360 bacteria per 1 hour or per hour. Okay, and number 25, the scatter plot shows the weight and fuel efficiency for each of the 21 vehicles. Also known is the line of best fit. So you got all these data points, okay? You took a weight and the fuel efficiency and you plotted that point for one truck or a car or whatever it is, vehicles. Then you have another one, take its weight and then its fuel efficiency. And they plotted all these points on a graph and then they found the line of best fit. Now, I think on the next page, yeah. On the next page, I think I can do this. We have the questions, okay? So, for these 21 vehicles, as weight increases, fuel efficiency does what? So, the weight is getting heavier, the fuel efficiency is going down. So it decreases, because these are our fill in the blanks over here. So the first blank is decrease. For these 21 vehicles, there is blank correlation between weight and fuel efficiency. They're talking about the slope. Is it a positive slope? Is it a negative slope? Or is it no? Meaning none. So it has a negative correlation because it's going down. Negative people bring you down. Using the line of best fit, we should predict that a vehicle weighing 3,500 pounds would have a fuel efficiency of approximately how many miles per gallon. Okay, so what we're going to do, let me see something, 3,500, because that's going to be about right in here. So if you come up on the line and then you go over, looks like it falls between that 25 and 30. So I'm going to say 27. The only thing that falls between those two is this here, between 25 and 30. So that is 27, whoops, where it is, miles per gallon. I'm just going to put mpg. Okay.